When you think about modern global engineering,
Right.
wow. I mean, whether it's complex product design or maybe coding for massive infrastructure, even planning huge construction projects, the speed, the scale, it's really something
It
else.
is astonishing.
But that speed, it creates this really tough organizational challenge. You've got teams scattered across, what, maybe 6 time zones?
Easily. Sometimes more.
Right. And they're juggling thousands of engineering revisions, maybe every single week, trying to figure out who changed what, when they did it, and crucially, why. Well, our source material calls it a daunting task, and that feels like an understatement sometimes.
It really does. The complexity is immense.
Yeah, and the old ways of managing change, they're buckling. They can't keep up, can they? They can't
Yeah.
really maintain the integrity of a design when you factor in simple human error or, communication delays.
They fall short.
Yeah.
Dramatically short.
So, for this deep dive, we really want to cut through the buzzwords. Our mission, if you will, is to understand exactly how these AI-enabled change management systems are stepping up. Not just to track revisions, but maybe to fundamentally change how shared engineering work happens.
Yeah, it's more than just tracking. We need to see AI here as almost like the ultimate institutional memory for these distributed engineering teams.
Right.
The big challenge for you, the listener, is shifting away from relying on, slow manual check-ins
Right.
and moving towards a system that gives you instant, reliable coordination.
Yeah.
AI basically takes over that role. It shifts the whole process from, let's say, reactive firefighting.
It's just exhausted.
Totally. To something more like real-time preemptive coordination.
Okay, let's unpack that. We hear AI automation all the time, right? But what are the specific capabilities? Maybe like the top 3 transformative things it actually does for revision tracking. Let's get specific on the mechanics here.
Okay, yeah. The transformation really hangs on, well, automation, like you said, but also foresight. So the first core capability is real-time collaboration and tracking.
Okay.
Now, that sounds simple, but the AI platform, it doesn't just, ping someone with an alert. It instantly updates all the linked data streams.
Yeah.
Making sure everyone, the architect in London, the manufacturer over in Shanghai, they're all seeing the exact current status of that revision. And this drastically cuts the risk of someone working off outdated information.
And that risk, it's not trivial, is it? We're talking aerospace, big infrastructure. A tiny mistake based on an old file, that can mean millions in rework. Or worse.
Oh, absolutely. Millions, easily.
Yeah.
Catastrophic failures in some cases. Which brings us to the second key feature, the automated revision logs. This tackles a reliability problem head-on.
How so?
Well, the AI tools automatically capture every single change, who did it, when, and the why. It creates this incredibly detailed, auditable history. But here's where it gets clever. The AI often uses NLP, natural language processing, to analyze the notes humans attach to the revision, the comments, the justifications. This lets it start to categorize the intent behind the change.
Okay, wait a second. If the AI logs literally everything, doesn't that just create a massive amount of, noise? How does an engineer sift through that? Find the critical safety update versus like 100 minor text tweaks?
That's a really important point. And it shows why just keeping records isn't enough. The NLP helps categorize severity, relevance.
Ah, okay.
And it provides filtering tools. So the system brings the important stuff, the signal, to the surface, not just all the noise. But the truly game-changing capability, that's the third one, predictive analysis.
Okay, now you've got my attention.
Right. This moves way beyond just logging what happened. It's about analyzing behavior. The AI looks at past revision patterns, not just design flaws, but process flaws.
Process flaws, like how people work.
Exactly. It might notice that, say, every time a specific offshore team merges code late on a Friday and they use certain older components, well, 48 hours later, a critical bug pops up.
Yeah.
By spotting these systemic risks, these behavioral patterns, the AI can actually predict potential bottlenecks or risks in the workflow itself. It lets managers step in before the problem even happens.
That's huge. You're literally shifting from cleaning up messes to managing behavior, managing institutional weaknesses before the failure. Okay, so we see the power. Now let's talk ROI. Let's prove it. For global revisions, what are the actual measurable bottom line benefits companies are seeing?
Yeah, if we accept that prediction and real-time sync are powerful, then the benefits become pretty clear, and they directly hit performance, profitability.
Okay.
So first off, there's a dramatic increase in efficiency. AI just takes over all that tedious manual stuff, tracking, documentation, compliance checks.
The grunt work.
Exactly, which speeds up the whole approval process for revisions. makes the entire product lifecycle leaner faster. Second, and maybe this is the most critical for you listening, is improved accuracy.
Right. Fewer mistakes.
By minimizing human error, both in documenting and sharing information, the AI ensures that all the teams, everywhere, are working from the single, true, most up-to-date and accurate version. No more confusion, no more wasted effort building on the wrong foundation.
So if an engineer gets back, say, 5 hours a week because they're not hunting for the final drawing,
Right.
that time goes into innovation, presumably.
Precisely. And that feeds right into the third benefit, enhanced collaboration. When people trust the data, trust the system.
Communication gets better.
It really does. Teams connect more smoothly, decisions happen faster, because they're not constantly bogged down trying to verify if they even have the right information.
Makes sense.
And finally, all of this adds up to significant cost savings. Streamlining the process, catching those predicted bottlenecks. It avoids major mistakes. It prevents incredibly costly rework. A single critical error caught late in a complex design. That can easily mean 6 figures in scrap, redesign. AI actively works to prevent that.
That cost avoidance, that's the number you can take to the bank. Okay, now this is where it gets really interesting for me. Let's ground this. Let's talk specific examples. Where are companies actually using this AI stuff right now for these complex global revisions?
Okay, great question. We've got a couple of strong examples showing how established software is baking this AI capability right in. First one is in the construction and architecture space. Autodesk's BIM 360.
BIM 360. Okay, I know BIM, building information modeling. Super complex 3D models, right?
Exactly. Highly complex. And the AI here, interestingly, uses computer vision. It actually looks at the 3D models.
Wait, computer vision on a structural drawing. How does that work?
Yeah. So imagine a structural engineer changes the size of a support beam in one part of the 3D model. The AI instantly sees that change and flags the discrepancy across all the linked documents.
Like the blueprints, the materials list.
The architectural drawings, the material procurement list, even the construction schedule. It tracks those changes in real time. This hugely minimizes mismatches out in the field, ensures the materials ordered actually match the correct design.
Okay, that's a powerful example. What's the second one?
The second major one is Siemens Teamcenter. This is a big player in PLM, product lifecycle management.
Right, PLM. Managing a product from cradle to grave, essentially.
Exactly. Used heavily in manufacturing high-tech development. Now, PLM is inherently complex because you're managing everything: design, production, service life, disposal. Teamcenter uses AI specifically to help those globally distributed teams manage complex engineering revisions. And it's not just about design integrity, it's crucial for ensuring compliance.
Compliance, like industry standards.
Yes, often multiple diverse industry standards, sometimes across different regulatory bodies in different countries. The AI helps manage that complexity too.
Okay, those examples really hammer home that this isn't just theoretical. This is foundational technology now, especially in these high-stakes industries. But, implementing something this complex, especially when companies have decades-old systems, there must be some serious headaches, right?
Oh, absolutely. It definitely raises an important question. We can't just talk about the benefits without looking at the hurdles. Implementation is, well, it's rarely perfectly smooth. You're wrestling with technical issues, security worries, and let's not forget the human element.
Let's start there, the human side, that classic resistance to change. It's got to be more than just people being annoyed about learning new software, isn't it?
It's much deeper than that, usually.
Yeah.
Particularly in engineering, the resistance often comes from maybe a fear of giving up critical control.
Wow, control, yeah.
Think about it. Engineers, designers, they're used to meticulously manually checking safety-critical revisions. They might be really hesitant to just let an algorithm handle that.
Trusting the black box.
Exactly. There's this deep-seated need to manually verify the crucial steps. Overcoming that reluctance, getting people to trust and adopt full automation, that takes a significant cultural shift. It takes time to build trust in the AI's processes.
Okay, so culture and trust. What about the tech and security side?
Well, then you run into some major technical and security walls. First, there are heightened data privacy concerns. We're talking about engineering designs, proprietary code, product specs.
Okay, sensitive stuff, trade secrets.
Extremely sensitive. Now, sharing that data across interconnected AI platforms, across different international teams, especially when different countries have wildly different laws about data residency and compliance, it creates enormous security and privacy challenges. You have to get that right.
And connecting that sensitive data to, like, the creaky old systems they already have, that sounds like a nightmare.
It often is the single biggest technical bottleneck: integration complexity. These shiny new AI tools, they can't just exist in isolation. They absolutely must connect smoothly with existing legacy systems, proprietary databases maybe built 20 years ago,
Hmm.
and they need to talk to dozens of other software packages via APIs,
Oh,
getting all those systems to communicate reliably. That often eats up huge amounts of resources, time, and specialized training before you even start seeing the benefits the AI promised.
Right, so the setup can be a major project in itself.
Mm.
Okay, so let's try and summarize the core idea from this deep dive. It feels like these AI-enabled systems are really driving a shift in global engineering towards efficiency, accuracy, and maybe most importantly, this idea of institutional memory. It's a fundamental change in how distributed teams handle complex revisions.
That's absolutely the key takeaway. AI isn't just a fancy spreadsheet upgrade. It's truly transforming how companies keep their designs coherent in real time, partly by predicting where human and process failures are likely to occur. And yeah, despite the big hurdles, the human resistance, the technical integration nightmare, the potential payoff, the potential for massive gains in efficiency, and avoiding those huge costs from errors, it really makes this AI layer an essential tool, as the source material puts it. It's becoming table stakes for companies trying to compete effectively in today's global market.
yeah.
You almost need it now for sustained competitiveness.
What really sticks with me is that predictive piece. That ability to predict behavioral failures, figuring out where things are likely to break before they do, based on how people have worked in the past.
That's powerful.
It really is. So if AI can do that for complex engineering designs, analyzing past revision patterns, what other kinds of ingrained organizational processes could benefit? Maybe things like, I don't know, high volume regulatory filings or large scale internal audits. Could they also benefit from that kind of predictive oversight? That's maybe something for you, the listener, to think about how this predictive capability might apply in your own field.